Layer 2 technologies. Switching is what layer 2 technology. We not only have routing, in network we also have switching. Meaning when the devices are in same local area network, means same subnet, we connect all those devices in the same subnet to a switch so that they all can communicate. For example, I have 10.0.0.1, 10.0.0.2, and many more. I just draw 4 now. All of these computers have got the same prefix 10, and the host ID is slightly different, 1, 2, 3, 4. But they all belong to the same network called 10/8. You don't need a router to communicate between this because these all belong to same network. Now, we call this as a LAN. This is what we call it as local area network. How do we communicate between these 4 devices? With MAC address or with IP address? It is, of course, with IP address. But to decide the final destination, we use IP address. To go to the destination, MAC address is what used. Whether it is LAN or WAN, it's the same story. If you ping from A to B, you are not using MAC address to ping that computer. You are going to ping using 10.0.0.4. But the switches, they don't deal with IP address. So what we do is when we send the packet, the ping packet, our source IP is 10.0.0.1 and destination IP is 10.0.0.4. There is also layer 2 information, right? We have MAC address, source MAC address. Let's say this MAC address is AAA and this MAC address is BB. So we need even the source and destination MAC address because the switches know only the MAC address of these devices. How switches know the MAC address of this device? We have a table in the switch called MAC address table. This table stores the MAC address of all these devices which are connected to various ports. Let's say this port number is F0/1, F0/2, F0/3, F0/4. And the MAC address is AAB, this is CCC, and this is DDD. We got 4 devices, 4 MAC address. Switches will learn these MAC address inside this table. How? When a packet comes, for example, I'm pinging from this computer 10.0.0.4. That's what you see here. 10.0.0.4. This computer knows its own MAC address, but it do not know the MAC address of 10004. It don't know. It don't know. So what this computer is going to do? It is going to send ARP, Address Resolution Protocol. It resolves the IP address into MAC address. So if you will just give the IP address to whom you want to talk, ARP will discover the MAC address for us. That's how this PC knows the MAC address of 10004. How ARP will know? How ARP learns the MAC address? ARP sends a layer 2 broadcast. ARP sends a layer 2 broadcast, meaning it will send asking who is 10004 to everyone in this switch. To everyone in the switch. As the packet goes, as the packet, our packet goes, our packet will go from A, and the destination it do not know, so it will say FFFFF 12 times F, 12 times F. That is what the broadcast address of MAC layer 2. Now when this packet approaches this port F01, switch will listen to the incoming frame source MAC. So it immediately learns that on F0/1, a MAC address called A connected. And now switch do not know where is 10004. So it is flooding this packet via all the ports that are available on the switch. The packet that went here will be dropped because this is 10002, but the incoming ARP request is asking who is 10004. So this computer says, it's not me, let me keep my mouth shut. And this is also going to keep its mouth shut because 10004 is not this one. Now this computer says, hey, it's me, what do you want? Who are you? How dare you call my name 10004 such loudly? And when he replies back, he puts his own MAC address as a source. And it hits the port F04. This is how F04 connected device MAC address BBB is learned. Likewise, when this computer communicates to this communicates to this, they learn the MAC address. This is how all these connected devices MAC address are learned into this MAC table. Now, we got this MAC addresses. Now switch knows who is connected where. Now when I ping, okay, one more minute. When the ARP reply comes, this PC now learned already in the ARP table that the MAC address of 10004 is BBB. So what it does is it puts that BBB now and send the packet to F01. When F01 reads this packet, it will read the source MAC address. Is it already learned? Yeah, it is learned. Now where should I send the packet? BBB. Okay, BBB is on F04. So instead of broadcasting, it will do unicast. It won't flood the packet to everyone this time. Why? Because it knows who is connected where. It knows everyone. The MAC table is fully updated. So when switch receives the packet, it will only see the destination MAC address to forward the packet. To learn the MAC address, it sees the source MAC address. But to decide on the destination, it sees the destination MAC address and looks into the MAC table, finds the exit, pushes the packet via the exit F04. That's how the packet goes. So it's not flooding. So whenever switch do not know a MAC address, if switch don't know a destination, it is going to flood. When the destination is known, it will unicast. When will a switch broadcast? This is a popular question in interview. When will a switch broadcast? When will a child cry in a shopping mall? When too many people and it couldn't find the parents. It will broadcast. It will shout, Mommy! It will shout. The whole floor will hear the voice. That's what called as broadcast. When it do not know the destination, switch will also shout so that everyone will hear. That is called broadcast. Switch floods the packet. But when the child knows that this mummy always goes to that beautician shop in that mall, that corner, all lipsticks and this, I know. Then this baby goes straight to that place and looks for mummy because it knows the destination. So when a switch knows the destination MAC address in the MAC table, it won't flood. It won't broadcast. It will do unicast. Now coming back to this layer 2 technology, switch learns MAC address, and when we do not know the MAC address to where MAC address location, for example, packet is coming with BBB. For some reason, someone refreshed the MAC table, so there is no entry for BBB. Switch will flood again, and then when the response comes from BBB, it learns when the response comes. Yeah. So this is how switch behaves. Now coming back to this real story, we have IP address to ping. We did not ping with MAC address. We pinged 10.0.0.4, but you see MAC address is involved in forwarding the packet to that computer. So without IP address, you will not know to which MAC address to forward the packet. So in order to point out a destination, you use IP address. To move the packet towards the destination, the intermediate devices use MAC address if it is layer 2 device. If it is layer 3 device, the intermediate devices they use, if the intermediate device is layer 3, they use the IP address. See, in a packet, both are there. We have both in a packet. We have both layer 2 address. When you capture a packet, you can see layer 2 source and destination, layer 3 source and destination. So wherever it has been read, these are the two things they look for. If it is switch, it will look for MAC address, the layer 2 field. If it is router, they look for layer 3 field. And they decide on the exit. Right. Now, how many devices can be connected to a switch? See, We also have 500 port switch, which means I can connect 500 switches to one group. Yeah, you can, but not recommended. See, in an office, if you have 500 employees, all 500 will not be in same department. They will all be in different departments. Sorry, so some of them will be in different departments. Yeah, in each department, let's say out of 500, like 30 people. Then we have 150 departments. Is it 150? No, 15 departments. Now, each department needs isolation from one another. Each department need to be in a separate group. You need to buy then 15 departments, 15 switch to keep them separate. If you connect all 500 computers, if any one send a broadcast, it impacts all other 499 computers, which is a disturbance. Actually, you belong to a department where there is only 30 people. Why will a broadcast done by your computer disturb all other 499 computers? You can only disturb 29 other people in your department, not everyone in the office. Not only that, if everyone is in one group, all 500 in one group, management, maintenance is very difficult. Not only that, if all are in one group, the employee will easily get into the computer of other employee who is in another department, because they're all in one single group. Easily they can get into others' business, which is not recommended, not allowed, should not be. Why will one department, without the other department's knowledge, gets inside their computer? Through network they can go. So how do you prevent this? We buy multiple switches and we give it to different department. That's one way. But I already told you, we also have a switch with 500 ports. If I have a switch with 500 ports, and if all of them are in one group, then it is very difficult to manage and not secured. One will get into the business of the other department. I told you just now all those stories. So, when I have 500 ports, why should I buy 15 switches for 15 departments? So we have to do something. What is that something? We need to logically divide the switch into group of 30. Assume that there are 30 ports. So another 30 port. Logically, I group them. In another word, I create a logical switch. I create a logical switches. Yep. So earlier it was one big switch, but now logically there are multiple switches. So now when I connect a device here and when it sends a broadcast, it will impact only these devices that are connected to these ports. They will not disturb the device which is on the other group. The broadcast that is sent from this black computer, I said black, this black computer will not go to blue. Why? Because they belong to different switch. Huh? Did I make a mistake in saying switch? No, no, no. I'm correct. This is a switch, virtually. Earlier, there was only one switch, big 500 port switch. But now I have created multiple virtual switches inside this physical switch. We call this as VLAN. Virtual LAN. I told you earlier, one switch is called as one LAN. The physical switch has got all the ports in one group. So it's a LAN. But now I created virtual switches inside the switch. Each virtual switch is totally isolated from one another. They are as if they are not. I'm not talking about as if and Muhammad. As if English is confusing. They are as if they are separate switches, real switches. If you have two separate switches, how they behave independently, same way. These virtual switches work independently. Even though they belong to a single physical switch, they all work independently. Means any broadcast in this domain will not impact other virtual switch. They are as if they are separate switches. They behave as if they are individual switches, but physically they are not individual switch. Virtually they are individual switch. So in another technical term, if I need to say, earlier all 500 ports were in single broadcast domain. What does that mean, single broadcast domain? Broadcast. Meaning, if any broadcast happens in one port, it impacts all 499 ports. Everyone get disturbed, which means they are in single group. That is what it means. Before we created VLAN, they were all in single VLAN. That is also actually a VLAN. All 500 ports were in a VLAN called 1. This VLAN cannot be deleted. This is called default VLAN. Now this VLAN you cannot delete, because by default all the ports in the switch will need to be member of this port. If you delete this, the switch won't function. No, they all need to be in one group by default. So you cannot first of all delete this, but I can create multiple VLANs and put some interfaces, like I have put here VLAN 10, 30 ports, first 1 to 30 port, VLAN 20, 31 port to 60 port, VLAN 30. This number You only decide. You can decide any number that you like. 30 device, 30 ports. So likewise, I can create logically groups so that one group, one VLAN will be separated from other VLAN. What does that mean? The traffic of one VLAN will not disturb the traffic of other VLAN. They are going to work as if they are in two different switches. Switches learn MAC address. When a packet arrives, if the destination MAC address is not found, switches will broadcast. When a destination MAC address is found, switches are going to do unicast. And in a switch, there will be one VLAN by default to which all the ports will be members. We can create multiple VLANs and allocate some interface, some ports. Taking from this VLAN 1, we can give to other VLANs so that you will have multiple virtual switches. Each virtual switch is a VLAN. Okay, how many VLANs can I create in a switch? How many VLANs we can create in a switch? You can have 4095 VLANs. 96. 4096. We can have only these many VLANs. Now you may have a question. What? The number of port itself is 500. Why you need 4096 VLANs in a switch? That's a good question. See, in a big organization, I'm just answering now, but in detail you will see in the next level CCNP. In a big organization, a few VLANs will be in this switch, few other VLANs will be in the other switch, and a few VLANs which was here in this switch will be in the third switch. Few VLAN in the second switch will be there in the sixth switch, and all these switches are interconnected. If a traffic from VLAN 10, okay, VLAN 100 needs to go to VLAN 100 here, you may not have any members of VLAN 100 connected in this switch. You may not have a member, but still, you must create that VLAN 100. Only then it will pass through. So, in a big organization, you may need this many VLANs. Or if there is a big layer 2 service provider, he needs this many VLANs to keep the customer traffic separate. Those things are too early for you. It's not in this program. Let's not focus on that. But one thing I want to say, maximum number of VLAN that a switch supports. Any switch on earth cannot support more than this. 4096 is the max. In a small switch, you won't even see this much. You will see only 1005. For example, if you see in packet reason, In a switch, I told you there will be one VLAN by default, and all ports will be member of that VLAN. First, let me show you that. See, the command. I don't want the switch. I'll take another switch because I made mistake. No, I put one slash, so it is searching for that slash. It'll take some time to come out, so I don't want to wait till it comes out. Let me go to the other switch. You see, in the previous switch, what I did is I put one slash and hit enter accidentally. There is no command, it is searching. Same mistake I'm going to do here, but it won't make me to wait like this. Okay, why? Because I'm going to put this command: no IP domain lookup. After you put this command, even if you make mistake, see, it comes out immediately. See, it still has not come out. Now only it has come out. In order to avoid wasting your time like this when you type mistake, do some wrong commands, better do this. No IP domain lookup. After that, you do whatever coupon, it will come out immediately. But without putting that, if you put coupon, it will again search who is coupon, who is coupon, who is coupon. It is broadcasting to everyone asking who is coupon. Fine. Now show VLAN brief. It says there are 24 ports and all these 24 ports belong to that one VLAN. Yeah, command is show VLAN brief. This is the command to see VLANs. And these are all default. By default, they are created, but they are not used. They are not supported. Cisco never supports this. These technology, FDD, token ring, these numbers are already reserved. Now, if you try to create a VLAN, you see VLAN, this is the command. In the global mode, type VLAN, put question mark. This switch supports only 1005. I told you the maximum number of VLAN is 4096. But only the high-end switches will support this big number. A simple switch can support only up to 1005. In that 1005 also, these are reserved. That's why I said 1001. So if you want to create VLANs, it should be less than 1002, means 1001 up to 1001. I'm going to say VLAN 100. So this creates a VLAN. Optionally, you can give a name. I want to give a name Noor. Noor. Okay, let's go and verify. Show VLAN brief. 100 VLAN Noor. But there is no interface given to this VLAN. All interfaces belong to the default VLAN. Now I'm going to take this 10 interface and put it in this broadcast domain. This is like a switch with no ports. You have created a switch called 100, but there is no port. I'm going to give some ports. See, this is the command. If you want to put all 10 interface, then you say interface range F0/1 F0/1 -10. Means I'm right now inside all the 10 interface. And I say switch port mode access. What does that mean? It means that these ports belong to a particular VLAN, not a trunk port. We'll talk about trunk port later. Trunk port will be a member of multiple VLANs. But as of now, switch port mode access, meaning this is not a trunk port. This is a member of a single VLAN. That's the meaning of it. Next, switch port access VLAN 100. So I have allocated this 10 interface to VLAN 100. Let's go and verify this. Show VLAN brief. Look at this. Only from 11 to 24, it is in default VLAN. Now we have taken that first 10 interface and we have given to Noor. Earlier, It was all in one switch. Now we have two switches. This is one switch. இது மற்றொன்று. இரண்டு சுவிட்சுகள் இப்பொழுது. பிசிக்கலாக ஒன்று. Physically it is one. But virtually it is two. Two switches. So today we have learned what is VLAN. VLAN is a broadcast domain. By default, a switch will have only one broadcast domain, means only one big group, only one broadcast control. All ports will be in one control. But by creating VLANs, we create multiple broadcast domain. Idu okati broadcast domain. Idu next one. So we got ಒಂದು ಎರಡು broadcast domain. By default, there will be only one broadcast domain, but we got now two broadcast domain. What is the advantage? When you have two groups, it is easy to manage instead of having all in one group. Not only that, is security. No one will interfere into Nuru business from default. Default is separate group, Nuru is another group. That's a security. It's like two physical switch. Right? So we started learning switches. Switches learn MAC address. If the MAC address is not known in the MAC table, it will flood. If the MAC table is known, it will do unicast. When the MAC table don't have MAC address, it will broadcast. We also learned that ARP resolves IP address into MAC address by sending layer 2 broadcast. We also learned that to ping someone, it is not only the MAC address needed, you also need an IP address. Without pinging with an IP address, you will not know to whom you want to ping. So those switches use MAC address. The MAC address of whom is determined by the IP address to which you ping. And then we understood what is VLAN and why we need VLANs. And we can have maximum of 4096 VLANs. And we also saw creating more number of broadcast domain increases means creating more number of VLAN increases more number of broadcast domain. If you have one single broadcast domain for all the ports, then it will be very difficult for the switch to handle the traffic. And if there is any sort of disturbance in that group, like broadcast, it will impact everyone. But if you have multiple groups, the disturbance in one group will not disturb the other group. They will be kept isolated. So isolation of problem, easy management, security, these are all the advantage of creating multiple VLANs. Any questions? Any question? Fine then.